queue via stacks. So in this question, we need to implement queue class, which implements a queue using two stacks. So we are given two stacks. We have to create a queue by using these two stacks over here. Now we know that the major difference between a queue and stack is the order of the elements, because we know that stack use last in first out methodology, and in queue we are using first in and first out. So this means that last in element comes first out in stack, and in queue first in element comes first out. So to implement the logic of queue using stacks, we can use our second stack to reverse the order of elements by popping out from stack 1 and pushing to the stack 2 over here. Then in this case, the order of elements will change. Then we can dequeue the elements from stack 2 over here. Now let's see how this is working in practice. So for example, if we enqueue elements to this queue over here by using these stacks over here, it's going to enqueue all elements to stack 1 over here. So we know that in case of stack, if I just call pop out method, it's going to pop out 7 from here. But in case of queue, if I call dequeue method, it has to bring out 5 over here. So how can we implement this logic? So as I mentioned before, we are going to use second stack to change the order of the elements in this case. So if I just pop out elements from stack 1 and push them to the stack 2, in this case the order of elements will be changed. So in this case it's going to work like this. So if I call dequeue method for this queue over here, it's going to pop out elements from stack 1 and move them to stack 2 over here. So in this case, as you see, the last element in stack 1 was 7, so it come out first and it's inserted to this stack over here first. So if I call one more time pop out element from stack 2, in this case the first element in our queue will come out, which is 5. So as you remember, first element that we have inserted to this queue, which is inserted to the stack 1, was 5. So if I call dequeue method, it has to come out in this case. Now if I call enqueue method one more time, this time enqueue method will enqueue the elements to the stack 1 over here. So our logic is like this. Every time when we are calling enqueue method, it's going to enqueue elements to the stack 1. And every time when we are calling dequeue method, it's going to remove element from stack 2. When the stack 2 becomes empty, then dequeue method moves all elements from stack 1 to the stack 2, in this case the way that we explained over here. So it's popping out from here and it's pushing over here. So the logic is very simple. Whenever we are calling enqueue method, it's going to enqueue all elements to stack 1, and when we are calling dequeue method, it's going to check that if the second stack is empty, it's moving all elements from stack 1 to the stack 2 in reverse order, and it's popping out elements from the stack until stack 2 becomes empty. Now this is how our logic will work. So let's head over to Java, implement this logic in practice. Now here, the first thing that I'm going to do, I'm going to create queue via stack class. So I'm going to add a new file, which will name be queue via stack class.java. Then inside this file, I'm going to create our class. So before creating our class, I'm going to import from utility library stack. I don't want to create a stack separately over here because we have it available in Java. So I'm going to import it from here. Import java.util.stack. So I'm going to use this stack from this library. Then I'm going to create our class like this, public class queue via stack. Now the first thing that I'm going to do in this class, I'm going to create two stacks. So these stacks will be the type of integer. So for simplicity, I'm creating the type of integer. You can create whatever type you want. So in this case, I'm going to create stack using this stack class over here. So it's going to be the type of integer. And here I'm going to create two stacks. So first stack will be the newest elements that we are going to import, which is stack 1. And the second stack will be the oldest elements that we have already inserted. So I'm going to name them like this. Stack newest, and the second one will be stack oldest. So whenever we are enqueuing elements, we are going to insert elements to this stack over here, which is stack newest. When we are dequeuing the elements from the queue, we are going to pop out the element from stack oldest. And whenever stack oldest become empty, in this case, we are going to move all elements from the stack newest to the stack oldest in reverse order. Now the next thing that I'm going to do, I'm going to create a constructor for this class. So it's going to be like this, queue via stack. So it's not going to take any parameter. Then here I'm going to instantiate our stack newest and stack oldest. So it's going to be like this, stack newest is equal to new stack. So this one also will be the type of integer because we have declared it as type of integer. So we are going to do the same operation for the stack oldest over here. So with this we have instantiated our stacks over here. Now next thing that we are going to do, we are going to implement the methods for this queue over here. Now the first method that I'm going to implement is size method. So by calling size method, we can get the size of this queue over here. So the return value of this method will be integer, then it's not going to take any parameter. So how can we find the size of this queue over here? So we know that in stack class, we have size method for this stack over here. So if I sum up the sizes of these two stacks over here, I will get the size of this queue over here. So I'm going to return something like this. Return stack newest dot size plus stack oldest dot size. So if I sum up the sizes of these stacks over here, because in both stacks we will have elements, so it's going to give us the size of queue. So it's going to give us how many elements we have in our queue over here. Now with this we have completed size method. So as you can see, it's very easy. Then the next method that I'm going to implement is enqueue method. So as you remember, when we discussed our logic, we said that whenever we are going to enqueue elements, we are going to push elements to this new stack over here. So we are not going to do an operation, we are just going to push elements to this stack over here. So I'm going to declare our enqueue method like this. Public void enqueue. So it's not going to return any parameter. So it's going to take the value of integer as a parameter. Then the only thing that we are going to do over here, we are going to push elements to the newest stack. So I'm going to call push method of the newest stack with the value that we are receiving from this parameter. So with this, we have successfully implemented our logic over here. Now our main logic will be implemented in dequeue method, because when we are dequeuing the elements, we are going to check that if the oldest stack is empty, we have to move all elements from the newest stacks to oldest stacks. So in this case, I need a helper function. So here I'm going to create a helper function which called shift stacks. So this function will check that if the oldest stack is empty, it's going to take all elements from the newest stack and insert all of them to the oldest stack. So I'm going to create our method like this. It's going to be private method because I'm going to use it only locally. So private void shift stacks. So it's not going to take any parameters. So here the first thing that I'm going to do, I'm going to check that if the oldest stack is empty or not. So if stack oldest is empty, okay, so we have is empty method for the stacks over here, then we are going to do something like this. While the stack newest is not empty, then in this case we are going to pop all elements from the newest stack and push them to the oldest stack. So it's going to be like this. While loop will be like while newest stack is not empty, then in this case I'm going to pop out elements from the stack. So here I'm going to create type of integer value, so it's going to be popped out. So I'm going to call stack newest dot pop. So this will pop out the element from stack newest and return that value. Then we are going to take this value and insert it to all the stacks. So I'm going to call all the stacks push method with this value. So with this, we have successfully implemented logic for shifting the stack. So what we are doing over here is we are checking that if the oldest stack is empty, in this case, we are taking all elements from the newest stack and pushing them to the oldest stack over here. Now with this, we have completed our shift stacks method. By using this method over here, we are going to create our dequeue method. Now here I'm going to declare our dequeue method like this. So it's going to be like this, public int dequeue. So it's not going to take any parameters. So as we said before, the first thing that we are going to do, we are going to shift the elements. So in this shift method, it's going to check that if the oldest stack is empty, then it's going to shift the elements. Otherwise, it's not going to shift. So I'm going to call this method before dequeuing an element inside this dequeue method. Then the next thing that I'm going to do, as we mentioned before, we are dequeuing the element from the oldest stack. So it's going to be like this, return stack oldest dot pop. So with this, we are popping out the first element that we have inserted to our queue over here. Now with this we have completed the queue method also. Now the next method that I'm going to implement is pick method. So we know that in case of queue, pick method returns the first element from the queue without removing that one. So in this case, I'm going to create our method like this, public int pick. So one more time we are going to call shift stacks, because in this case also we have to identify that which one is the first element. So that's why we have to move all elements from the newest stack to the oldest stack if the oldest stack is empty. Then we are going to return the element from the oldest stack, because the top element of the oldest stack will be the first element in the queue. So that's why without calling pop method over here, I'm going to call pick method of the stack over here. So we know that pick method in case of stack is not removing the element from stack, it's just returning the top element. So that's why I'm going to do it for all the stack over here. So with this, we can successfully return the element which is located at the beginning of queue in this case. Now with this we have completed pick method also. Now let's see how this is working in practice. So inside main class, I'm going to create an instance of the queue via stack class. So it's going to be like this: new queue is equal to new queue via stack. Then I'm going to call in queue method few times. Then I'm going to call the queue method to see how this is working. So I'm going to do it like this: 1, 1, 2, 3. Then inside print function, I'm going to call the queue method. So here I'm going to call the queue method. Now we can easily see that the first element that we have inserted to our queue is 1. So when we are calling the queue method, it has to return 1 in this case. But in case of stack, it should return 3 because the 3 is the last element that we have inserted over here. Now if I call our method, you'll see that in this case it returned 1. Now if I call the queue method one more time, it's going to return 2 in this case because the second element in the queue is 2. As you can see, it's returning 2 over here. Now, for example, if I enqueue one more element between the queues over here, for example, 4, what will happen? So in this case also it has to return 2 because the second element is not changing, so the second element in the queue is 2. So everything works the way that we want. Now instead of the queue method, I'm going to call pick method to see how this is working. So in this case, pick method always has to return the 1 in this case because 1 is the first element in our queue. So we are not removing an element from queue, we are just checking that which element is the first element. So as you can see, for both cases, turning 1 over here. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented a queue using 2 stacks over here. So hopefully everything is clear about this question over here. Now see you in the next question.